Yesterday, we focused on how to find the scale factor when given two sets of information, an original and new image. Today, we are looking at how two figures can be identified as similar. So if we look at the first part, it says that similar shapes have the same shape, but not necessarily the same size. Corresponding angles and corresponding sides of two or more similar shapes are in the same relative position. So go ahead and write those terms that are highlighted in your journal. This symbol, it kind of looks like a wavy line, means is similar to. And in this figure shown below, shown sides and angles that are the same color correspond to each other. So we're going to use different symbols since we don't all have colors. So this symbol, this side and this side correspond, therefore they both have hearts. These two correspond, therefore they both have stars. And these two correspond, therefore they both have triangles. Whatever symbol you want to use to show their corresponding, or in other words, that they match. And these two phrases I would like you to write down in your notes, specifically these parts. In two similar figures, the measures of corresponding angles are equal. So that phrase. And the lengths of the corresponding sides are proportional. Lengths are proportional. So we're going to read this problem aloud, and we're going to determine if the shapes that we have are similar. And so we have the important information we need to keep in mind as we go through the problem. So here we go. We're going to explain whether these two triangles are similar. So the first thing we need to ask ourselves, are these two shapes facing the same direction? Yes, I see that this side is flat, and this side is kind of leaning to the left, which matches what we see over here. So they seem to be facing the exact same side, same direction. And now we notice that the triangle FED, remember we can write triangle FED, is smaller than triangle QRS, right? We just read the angles, the letters next to the angles, and that's the way we identify them. So since it is smaller than the other triangle, this is an enlargement. So let's go ahead and make note of that. It is an enlargement of the smaller triangle. So the next thing we need to do is label the corresponding sides with symbols, just like we did in the above picture. So I see that this side FE matches with this side RS, so I'm going to put two hearts there. I also see that this side FD matches with side SQ, so I'm going to put two triangles to show that those match. And then ED matches the side RQ, right? They're going the exact same direction. They're the exact same place of the triangle. So now that we have put symbols on each of the corresponding sides, we can then determine if they are similar. So how do we do that? Well, if these shapes are similar, they need to have the exact same scale factor. Well, how do we find the scale factor? Well, I know that I can pick a pair of points and write it as a ratio of new over original to see what we get. So to find the scale factor, we write new over original, so new over original. So I can pick any of these two or any of these pairs to set up my ratio. So I'm going to pick 12 and 36. Well, this is the new image, and this is the starting or the original image. And so I'm going to write it as 36 over 12. Can we simplify 36 divided by 12? Yes, we get 3. Okay, so if the scale factor is 3, then that means every dimension on the other triangle, right, on the original triangle, would be multiplied by 3 to get the new dimensions. So let's see if that's true. So we're going to set up our table, original, and the scale factor is 3, so that means we have to multiply by 3 to get the new dimension. So I'm just setting a table to help organize my information. And we have 8, 7, and 12. So we need to multiply 8 times 3, which we get 24, 7 times 3, which we get 21, and 12 times 3, which we get 36. So let's go and check in our drawing if those match. So I see 8 matches with 24, yes. 12 matches with 36, yes. And 7 matches with 21. Love it. So what does that mean about these triangles? They are proportional and they are similar. So let's enter that in our complete sentence. The following triangles are similar because their sides are proportional. Or we can say they have, and because they have a scale factor of 3. That also shows that they are proportional because every single side is multiplied by 3 to get the new side. So let's stamp. We're going to first identify the corresponding sides using symbols. We then find the scale factor by dividing the new dimension over the original. And if all the sides are proportional, then that means these shapes are similar. We're going to try one on our own.